This is a random value property. So what it says is if f of x is equal to g of x when x is not equal a, then the limits of each are equal, provided that the limit exists. So I've got a little example here to show you what this is going on. So think about it this way. G of x is this blue one. So we have a line here that goes here, but at this value, it's open and the value is here at 3. So our g of x is defined at x equals 1 and x not equal to 1. But the value of the limit as x approaches 1 does not depend on the value of the function at 1. So think about it this way, how the property is saying. There is an actual line that you can think of as going through here, and we can call that one f of x. So g of x is the blue one, f of x is the red one. And our limits say coming in from the left and the right, what are we approaching? So you can see that coming in from the left and the right of both g and f, they're both approaching the same number, 2. So with this, it's saying that if f of x is equal to g of x when x is not equal to a, that's where our limit is going, then the limits are equal. So we can say that the limit of limit of g of x as x approaches to 1 is exactly the same as the limit of f of x. And we can make our f of x the value where x does not equal to 1. That applies to this. So this really becomes the limit as x approaches 1 of x plus 1. So our f of x is x plus 1. And they are equal to g of x for x not equal to 1. Right? So f of x is equal to x plus 1, g of x is equal to x plus 1 when x is not equal to 1, and our limit is going to 1. So it allows us to just say, well, we don't care what's going on at that random value here. This is just some random value sitting out there. Who cares? It does not affect the limit. So now we can just use our direct substitution property, plug it in, and we get 2, which is what we had in our picture. So coming in from the left and the right, we get 2. This works really well with piecewise functions. You just want to look at the value that we're approaching, and you can see what it gives us. Thank you.